Now we're gonna look on something called cross-validation, and in this discussion we have something like what is difference between train, test and validation, what is cross-validation, and after that we'll be discussing types of cross-validation. Then we'll be looking something as grid search and randomized search, and at the last there will be practical implementation. In Python. So without wasting much time, we can look at this, which is something called difference between train, test and validation data. So let's say we have our data and we want to perform something like regression or classification. So what we can do, we have, let's say, our data set, and let's say it have this f1, f2, f3, f4 features as input, and there is one output. Okay, so in our data set, what generally we have this kind of data set, and some of the columns represent input, and maybe the final column represents the output. This can be feature 1, feature 2, feature 3, feature 4, and there are, let's say, n entries. So based on this inputs, we predict this output. So the process of machine learning goes like that. First, we have data pre-processing. Let me write it clearly. Data pre-process, pre-process. Okay. Or then we'll have feature engineering. After that, we'll go for feature selection. Then we'll going for model training. At last, we'll be having hyperparameter tuning, and finally we'll be having our model which we can train and basically test. This is the general procedure of machine learning. So what we can have in this process, the main aim is to divide data set, but how to utilize it. So there are, you might have already heard of train, test, split. So in this, what we are doing, we are having a data. We'll be dividing it into two parts, train and test. We'll be training our model on this and testing our model on this. Okay, but here comes a problem that in case your data set is small, so what will happen if you divide, let's say, 70% into train and 30% into test, and over here, since you have less amount of data, then you might don't have a proper amount of samples to train. So in general procedures to firstly avoid leaving any data, and one more important thing, that is called hyperparameter tuning. We use something called a test, train and validation split. So for example, this is your data. You will be dividing into three parts. First is train, second is validation, and the last is test. So what is the purpose of each and everything? Let me show you. Training is for model training, you all know. Test is for model performance evaluation. So here's come the question that what is the purpose of validation? Before that, we can have that, let's say you have test data. We will be obviously looking for model performance. Or we can evaluate with the help of performance metrics. So what are these performance matrices? Performance matrices. Let's say you have accuracy, precision, recall, F1 score, etc. etc. Okay, these all things we can do. So what is the validation? The question is, what is validation data? Okay. We have mentioned that it is used for hyperparameter tuning. So what are hyperparameters? First question comes here. So hyperparameters are nothing but external parameters. For example, you have your learning rate, number of iterations, number of estimators, etc. So how it is happening? Because let's say you have a model. It is associated with all of these: the learning rate, number of iterators, and number of estimators, and etc. So what will happen? Your model's performance will change based on this all thing. So let's say you take alpha equals to 0.1, and then you take 10, then 0.5, then you take 1 e to power minus 3, so basically 0.0001. So based on changing this alpha values, our model performance will either increase or decrease. So this is what basically called as hyperparameter tuning. Based on alpha and iterator, number of estimators, etc. So this is called hyperparameter tuning. For this purpose, we use validation data. So what's the procedure? Let's first see. So you use basically something called CrossValidation. So let's say you have 10,000 records. Out of it, we divide it into train and test. Train and test into, let's say the number may be 8,000 and 2,000. So now, if we use CV equals to 5, means cross validation into 5, then we'll be dividing this into 5 parts, and each part of whatever equivalent. So let's say this is CV, and this is 1600, and this is 17400, because each part will be of 1600, right? If we divide it equally. In first iteration, we'll be using it for validation, and this will be used for training. This is first iteration. In second iteration, what we'll be doing, we'll be using this middle portion into validation and remaining on training. Let me draw it clearly here. In the first iteration, what we are doing, we'll be using it for validation and remaining for training. This is first iteration, and this will give you some accuracy 1 A1. In second iteration, we'll be using remaining and remaining for the training. This will give you some A2, and so on. You will be doing some AN iteration. That depends, and after that you will be calculating average. So in this way, what you are doing, you are utilizing, you are utilizing whole training data efficiently. Moreover, let's say what we are doing, we are having different splits. Let's say this was one split and this was another split. For this, it was validation and it was training. For this is training, let's say, and this is validation. So what is happening, let's say, to test the model performance, let's say for this we use alpha equals to 0.01, and for this we use alpha equals to 0.0001, and we'll see that which all performs good. So this is how validation is done. Okay, and this is how we can do hyperparameter tuning. So next we'll be looking at different types of cross validation in detail and try to get more intuition. Thank you.